If you throw a die, let x be the number you get on the die. If you throw the die 100 times and then calculate the mean, that in turn will be a random variable, because every time you repeat this, you will get a different mean. So let's say the first time you do it, you get this mean. Then we do it again. We throw the die 100 times and then see what the mean is. Then perhaps we got this one. And then we repeat again, throw 100 times, and then maybe we got this again. If we repeat this many times, then we start to build up here. And after a while, we will get the curve looking something like this. So we'll have the frequencies here, the number of times we've gotten a certain mean of x. And here you see that it resembles a normal distribution. And this will always happen if n is just large enough, and as a rule of thumb you take it larger than 30. And that's called a central limit theorem. So if you take any random variable and take the mean of that in n observations, then the mean will be a random variable that is normally distributed. And that is called a central limit theorem. So the central limit theorem says that if you have a random variable with expectation value mu and standard deviation sigma, then the mean of x will be another random variable that is normally distributed with the same expectation value and the same standard deviation, but divided by a square root of n. So here x doesn't need to be normally distributed, but the mean will be, if n is larger than or equal to 30. And if n is not larger than 30, but x is normally distributed, then this will also be normally distributed. So x mean will not be normally distributed only if x is less than 30 and x is not normally distributed. So if x is normally distributed with this expectation value and this standard deviation, then we have seen before that you can form a standard normal distributed random variable by subtracting the expectation value and dividing by the standard deviation. And then we call this set. For example, if I want to calculate what is the probability that I will get a mean larger than some value c, then I can just change to set if I subtract by the expectation value and divide by standard deviation. And this I can use a table to check. Previously we saw this theorem that if you have a random variable that is normally distributed, then with probability 1 minus 2 alpha, x will have an outcome in this interval. And since the mean now is a random variable that is normally distributed with this standard deviation, it will get an outcome in this interval with this probability. For example, if n is equal to 5, that if we do 5 observations of x, assume that x is normally distributed. Then the mean will also be normally distributed according to the central limit theorem. Let's say we want to calculate the probability for x mean to be larger than 110. Then we can just first change to set standard normal distributed by doing this, where we have the expectation value standard deviation. And here n is 5. So this becomes the probability for set being larger than 1.49. And this we can check in the table. And then we'll find this to be 6.81%. Assume that you do 11 observations of x that has an expectation value of 5 and standard deviation 2. And you want to determine the probability for the mean to be larger than 6. However, since n is not larger than 30, then we can't say that this is normally distributed. If x would have been normally distributed, this would also be, but we don't know. So we don't know if x mean is normally distributed, so we cannot calculate it using what we have learned about normal distributions. So in this case we cannot come any further on this probability using normal distributions. However, if for example we have changed this to 31, then we could have continued calculating, because then this will be normally distributed. Assume that x is a random variable with expectation value 10 and standard deviation 3, and that we do 100 observations of x. In this case, n is larger than or equal to 30. So we know that the mean will be normal distributed with the same expectation value, but with the standard deviation 3 divided by square root of 100. That is 3 divided by 10. Then we can use this result here. And let's say we want to find out with a probability of 95%. And that means that alpha is 2.5%, which means that set alpha is 1.96 by checking in the table. Then again, according to this, the mean will be in that interval with 95% probability, and that interval is the expectation value minus set alpha times the standard deviation, this one, and the same with plus. Which is this interval. So with 95% probability, the mean will be in this interval.